Welcome back. Now we are going to continue with part two of, or part B of section 12, 2, chapter 12, section 2. So earlier we saw how to add two vectors by triangular law and or by parallelogram law. Now we will see how vector representations work. Like if you have a vector starting at the origin and ending at P, and P has coordinates A1, A2, A3. And you know that when you represent vector, then you can write this in component form, A1, A2, A3, like that. But if you can also start the vector, the same vector can be represented by the vector below, by the vector AB. You can also start the vector at a different point as long as the length of the vector and the direction of the vector are maintained, then these two vectors, the first vector OP vector and the vector AB, are one and the same, or that considered equivalent vector. So you can start the vector at the point x, y, z, and then add the components a1, a2, a3. So it becomes b. The vector, the point B has the coordinates x plus a1, x plus a1, y plus a2, and z plus a3. So vector OP and vector AB are equivalent vectors. So the vector AB, vector OP, and vector AB are equivalent vector or equivalent vectors. So this idea will be very useful later on in our problems. So vector representation is always the component form, A1, A2, A3. And then if you write a point, point P is in the coordinate form, A1, A2, A3. If you write vector A, it should be in the angle bracket A1, A2, A3. How do you find a vector from one point to another point? The vector from the point A with coordinates x1, x1, y1, z1 to the point P, x2, y2, z2 is given by the vector angle bracket. So subtract the corresponding components starting from the components of B minus components of A. So x2 minus x1, y2 minus y1, z2 minus z1. So this is the vector representation of the line join of A and B. Vector AB is represented by angle bracket x2 minus x1, y2 minus y1, z2 minus z1. So this exercise, example number 4, it's a problem from the exercise. This problem is done in the section videos, videos for section 12.2. So you may want to refer to the video part for this particular problem. The next concept is about magnitude and length of the vector. The magnitude or length of the vector V is the length of any of its representations and is denoted by the symbol kind of absolute value vector V or double lines to denote the length. By using the distance formula to compute the length of the line segment OP, we obtain the following formula. The length of the two-dimensional vector A, which has components A1, comma A2, which has components A1, comma A2, is represented by square root of A1 square plus A2 square. The same thing, the length of the vector in three dimension three-dimensional system, if A has components A1, A2, A3, then the length of A is denoted by square root of A1 square plus A2 square plus A3 square. You may want to memorize these two formulas. If A is a vector A1, A2, B is a vector which has components B1, B2, then vector A plus B has components A1 plus B1, A2 plus B2. You are adding just the corresponding components. In order to find the difference of the vector A minus B, then you are going to just subtract the corresponding components, A1 minus B1, comma A2 minus B2. Scalar multiple of a vector, C times A, you have to multiply each component by the scalar. Make a note of that. Similarly, for three-dimensional vectors, if you're adding two vectors, you're going to add the corresponding components. If you're going to subtract, then you're going to subtract the corresponding components. The scalar multiple of a vector is every component is getting multiplied by the scalar. Problem number 19 is done in the section video. Please refer to the section video. This problem is done in that part. We denote V sub 2 to represent the set of all two-dimensional vectors, and V3, V sub 3, to the set of all three-dimensional vectors. More generally, we will later need to consider V sub n of all n-dimensional vectors. A has components, n components, A1, A2, etc. up to AN, where A1, A2, A3, etc. AN are real numbers that are called the components of vector A. So we have the following properties of vectors, which are kind of trivial ones. If A, B, C are vectors in V sub n, and C is a scalar and D is also a scalar, then we have these properties: A plus B equal to B plus A, vector addition is commutative. Then associative, A plus B plus C, B plus C, you can add A with B plus C, or you can add C with A plus B. So it is known as, this property is known as commutative. This property is known as associative. Then A plus 0 equal to A, which is additive identity. Then A plus minus A equal to 0, and C times A plus A is C, A plus CB. C plus D times A is CA plus DA, kind of distribution. Then CD times A is C times DA, 1 times A equal to A. There are some vector properties. The three vectors in V3 play a very special role. They are vector I, which has components 1, 0, 0, vector J, which has components 0, 1, 0, vector K has component 0, 0, 1. These are three special vectors called standard basis vectors. These three vectors are called standard basis vectors. We will be using them quite often. These are unit vectors, also called standard basis vectors. Similarly, in two-dimensional, the standard basis vectors are I, which have components 1, 0, 1 and 0. J has component 0, 1. So I is a vector along the x direction, J is a vector along the y direction, and K is a vector along the z direction. If you look at this picture, it is I, which has components 0, 1. The coordinates wise, it's 1, 0. If you represent this as a vector, it becomes an I vector. Similarly, the J vector is this vector, which is 0, 1, which is the endpoint coordinates. But if you start from 0 and end at that point 0, 1, then it becomes a vector, which is a J vector. Similarly, I, J, K vectors are shown in this figure for 3 dimension. How do you write any vector A, which has components A1, A2, A3, using standard basis vectors? So this is an important information. A, which has components A1, A2, A3, I can write this as A1, comma 0, 0. Then I can write 0, A2, 0. And the third vector can be written as 0, 0, A3. I can write A1, A2, A3 as sum of 3 vectors like this. Because what is vector addition? You have to just add the corresponding components. So A1 can be written as A1 plus 0 plus 0. So then A1 is after all a scalar which can be taken out, and you can write like this, plus A2 can be pulled out, and 0, 1, 0. And A3 can be pulled out and be written as 0, 0, 1. So which means that it's A1, this is a standard basis vector I, then A2, standard basis vector J, plus A3, the standard basis vector K. So any vector A having components A1, A2, A3 can be written in terms of the standard basis vectors in this form, A1I plus A2J plus A3K. This again will be used quite often in our problems and in general for any use of vectors. What is a unit vector? Unit vector is a vector which has unit length, whose length is just 1. The unit vector is a vector whose length is 1. For instance, I, J, and K are all unit vectors. In general, the unit vector U in the direction of A, where A is not equal to 0, is A divided by length of A. If you have A divided by length of A, then that will be unit vector. The reason is, what is a unit vector? We have to only prove that the length is 1. So if you take the length of this vector, then you have to take the length of A over length of A. So length of A is after all magnitude, which can come out of the absolute sign. So it is absolute A over absolute A, or magnitude of A over magnitude of A, which is equal to 1. So unit vector in any direction of in the direction of A is the vector A divided by length of A. So problem number 25 and problem number 29 are done in the section videos. Refer to for both the problems, both 25 and 29, refer to the video section. Then what is one application of these vectors? There are several applications. In this section, we are going to see one application. Vectors are useful in many aspects of physics and engineering. In chapter 13, we will see how they describe the velocity and acceleration of objects moving in space. Here we look at forces. A force is represented by a vector because it has both a magnitude measured in pounds or newtons and a direction. So a force has both magnitude and direction. The magnitude could be either measured in pounds or newtons, and it has a fixed direction. If several forces are acting on an object, then the resultant force is experienced by the object is a vector sum of these forces. So the resultant force is the vector addition of the forces. In this problem number 32 is done in the section video. Please refer this problem, the section videos. I have done this problem in the section videos. There are several problems that are done in the section videos. Problem number 4, problem number 19, so the earlier ones that I mentioned, they are all done in that part. So this 19, problem number 4, problem number 19, then problem number 25, 29, 32, and also 31. And all these problems are done in the section videos, which will be very helpful to complete the homework problems too. Please do watch all these problems in the section videos. See you for the next section concept video, 12.3.